Welcome back. This is tutorial 8A. We are going to do question 5C. In this question, we are given x, where x is a complex vector. X is the DFT of small letter x. N is given to us, and big N is 4 times this vector, this column vector. And we are asked to find small x. And in fact, this question is very related to question 5b, because you can see that the coefficients are identical for the second element of this big X. The only difference is the first element. So the question also suggests to find the equation of small x by inspection. So let's proceed. This page is a solution. I'm going to use this page to explain. The first thing I'm going to say is that we're going to use the IDFT matrix. This is the equation of the IDFT matrix to reconstruct xn. So IDFT, the synthesis equation is this: 1 over n wh xk. We're given xk. So this is xk. This is 1 over n. Capital N is 4. So the only unknown is wh. From our notes, we know that wh looks like this. This is wh. wh, every element is e to the positive j 2 pi over nk. So this is the element e positive j 2 pi over nkn. They are the elements of wh. The 1 over n is here, and the xk is here. So we use this equation, and now we can fill up the wh matrix. To proceed, we are going to decompose wh into columns. So column 0 of wh, column 1, column 2, column 3. And we are going to put our vectors here: 2, 3e minus j pi over 4, 0 and 0. The 4, the n here, because it's n times this vector, cancels with this n. So we are only left with this wh multiplied by this vector. The 0 is going to multiply with this column and this column. So since they are 0, therefore these two columns are useless. We recognize matrix vector multiplication as simply this value multiplied by the first column, as well as the second value multiplied by the second column. So we write it here, the second value and the first value here, 2 and 3e minus 4, multiplying by the corresponding columns of k of wh. Now, therefore, all we need is to fill up the corresponding columns using e plus j 2 pi over n kn. So k is 0 for the 0th column, k equals to 1 for the first column. Now, once we can do that, then we fill up the corresponding numbers here. This is k equals to 0. This is k equals to 1. And here is n running from 0 to n minus 1. So once we have filled up these numbers in complex exponential form, then we convert it into rectangular form. So this first column, since it is ej to the power of 0, all the values become 1. Here, we recognize as this 2 pi over 4 times 1 becomes pi over 2. And this is pi over 2 radian per sample. And we observe the index n equals to 0, 1, 2, 3 running. So we then recognize it as a complex exponential rotating. Now it's plus, so we are rotating anti-clockwise as we are moving down time. So we fill up this number 1j minus 1 minus j. And then this is the final answer that we get. But this is not the form that we really want. We want it as an equation. So what we do is that we introduce the notation capital N equals to 4, small n equals to 0 to n minus 1, and we say xn is equals to 2 for this sequence, n equals to 0 to n minus 1. So 2 is 2 times all this, plus this coefficient is this coefficient here, these 2, times this is the sequence, this is the first column of WH. Now we can collapse this 3e minus j pi over 4, e plus j 2 pi over 4, and we collapse it, we bring the 3 out, the exponent can be brought inside to become the phase shift of this sequence. Okay, so that's it. Thank you.